The oxygen sensor, also known as the O2 sensor, is a crucial component in a car's engine and emissions control system. Its main function is to monitor the amount of oxygen present in the exhaust gases coming out of the engine after combustion has occurred. The sensor is usually mounted in the exhaust system, either in the exhaust manifold or the exhaust pipe. The oxygen sensor works by generating a voltage signal based on the concentration of oxygen in the exhaust gas. It contains a chemical element that reacts with oxygen, causing changes in its electrical conductivity. The difference in oxygen levels between the exhaust gas and the surrounding atmosphere creates a voltage signal that varies between high and low voltages. The engine control unit, ECU, of the car uses this voltage signal from the oxygen sensor to determine whether the engine is running in a rich, excess fuel, or lean, insufficient fuel, air-to-fuel ratio. By monitoring the oxygen content, the ECU can make real-time adjustments to the fuel injection system, ensuring the engine operates efficiently and meets emissions standards. There are typically two types of oxygen sensors found in most modern vehicles. Heated oxygen sensor, HO2S. This is the most common type and is used in most cars today. It has an internal heating element that helps it reach its operating temperature more quickly, improving accuracy and efficiency. Unheated oxygen sensor. Older vehicles may have unheated oxygen sensors, which do not have a built-in heating element. These sensors take longer to reach their operating temperature, which can lead to slightly reduced fuel efficiency and emissions control. The heated oxygen sensor is indeed the most common type of oxygen sensor used in modern cars. As mentioned earlier, it is equipped with an internal heating element that allows it to reach its operating temperature quickly. This feature is crucial for the sensor's accurate and efficient functioning. When an engine is started from a cold state, the exhaust gases are not hot enough to heat the oxygen sensor to its required operating temperature. The HO2S heating element helps to raise the sensor's temperature rapidly, allowing it to reach its optimal working condition faster. The benefits of having a heated oxygen sensor include improved accuracy. The heated sensor reaches its operating temperature quickly, which ensures that it can accurately measure the oxygen content in the exhaust gases from the moment the engine starts. This information is crucial for the engine control unit to adjust the air-to-fuel ratio appropriately and optimize combustion efficiency. Reduced emissions. The faster the oxygen sensor reaches its operating temperature, the quicker the engine control unit can enter its closed-loop mode. In closed-loop mode, the ECU uses real-time data from the oxygen sensor to fine-tune the fuel injection, leading to reduced emissions and better fuel efficiency. Faster response time. The heated oxygen sensor's ability to heat up rapidly also improves its response time to changes in the air-to-fuel ratio. This quick response allows the ECU to make more precise adjustments to fuel delivery, resulting in smoother engine performance and reduced pollution. The heated oxygen sensor plays a vital role in modern engine management systems, contributing to better fuel economy, lower emissions, and overall smoother engine operation. It is a key component in meeting emissions standards and ensuring the vehicle operates efficiently and cleanly. Regular maintenance of the oxygen sensor is essential for the proper functioning of the vehicle and to prevent potential engine issues or increased emissions. Over time, the sensor can become contaminated with carbon deposits and lose its accuracy, leading to performance problems and triggering the check engine light. Replacing a faulty oxygen sensor can help ensure the engine runs efficiently and reduce harmful emissions. There are several symptoms of the heated oxygen sensors. A faulty or failing heated oxygen sensor, HO2S, can lead to various symptoms that may indicate there is an issue with the sensor or the related components. Some common symptoms of a problematic HO2S include check engine light on. The most common indicator of an oxygen sensor problem is the illumination of the check engine or service engine soon light on the vehicle's dashboard. The onboard diagnostic system, OBD2, detects irregularities in the sensor's readings and triggers the warning light. Poor fuel economy. A malfunctioning oxygen sensor can cause the engine control unit, ECU, to operate in an open-loop mode, causing the engine to burn where it uses default fueling strategies instead of adjusting based on real-time sensor data. This can lead to reduced fuel efficiency and increased fuel consumption. Rough idling or poor performance. An improperly functioning oxygen sensor can disrupt the air-to-fuel ratio, leading to rough idling, hesitation, or a noticeable drop in engine performance. The engine may feel sluggish and less responsive than usual. Increased emissions. Since the oxygen sensor helps regulate the air-to-fuel ratio, a faulty sensor can lead to increased emissions, including higher levels of nitrogen oxides, NOx, carbon monoxide, CO, and hydrocarbons, HC. Failed emissions test. A malfunctioning HO2S can cause the vehicle to fail emissions tests since it affects the accuracy of the emissions control system. Stalling or surging. Inconsistent readings from the oxygen sensor may result in engine stalling or surging while driving, especially during sudden changes in throttle input. Poor cold start performance. If the oxygen sensor takes too long to reach its operating temperature, it can cause poor performance during cold starts, leading to rough idling and higher emissions until the sensor warms up. It's essential to address oxygen sensor issues promptly to avoid potential damage to other engine components and to maintain optimal fuel efficiency and emissions performance. If you experience any of these symptoms or have a check engine light illuminated, it is recommended to have your vehicle inspected and diagnosed by a qualified mechanic or automotive technician. They can use diagnostic tools to read trouble codes and determine if the oxygen sensor requires replacement or if there are other underlying issues affecting its performance.